Do you know how far humanity has actually traveled into the universe? Not how far we have imagined, or dreamed, or written about in science fiction, but how far we have truly reached with real machines, real physics, and real time. Most people would guess another star. Some might say the edge of the solar system. A few might even imagine distances measured in light years. But the real answer is far more unsettling. The farthest human-made object in existence is Voyager 1, a small spacecraft launched in 1977. After nearly 50 years of non-stop travel, after leaving the influence of the Sun and entering interstellar space, Voyager 1 is only 24 light hours away from Earth. Not days, not months, not even a single light year. That single fact changes everything, because the nearest star beyond our Sun is more than 4 light years away, over 1,000 times farther than the greatest distance we have ever reached. Suddenly, the universe no longer feels like a place we are slowly conquering. It feels like a place defined by separation. This is where the idea of the light year becomes deeply misunderstood. It isn't just a convenient unit for astronomers. It is a measure of isolation, a boundary drawn by the speed of light itself. Stay with me, because understanding what a light year truly means will quietly transform how you see distance, time, communication, and how small humanity really is in a universe that obeys no sense of scale we were ever meant to understand. The numbers we just touched are still hanging in the air, like a faint afterimage on your retina. So before they fade, let us examine the thing that tried to hold them, the human mind that insists it understands distance, even when it does not. When astronomers say that the Sun is about 149,600,000 kilometers away, that sentence passes easily through language. You can repeat it. You can write it down. It feels like information you now possess. But try to feel that distance in your body. There is nothing to hold on to. No memory matches it. No walk. No drive. No flight. The number slides straight through the part of you that knows what a street feels like, what a neighborhood feels like, what it means to be far from home. At smaller scales, your brain does very well. It understands the distance from your bed to the kitchen, from your apartment to the corner store, from your house to the friend who lives 2 bus stops away. These are distances you have occupied with your muscles and your lungs. Your sense of far comes from the time your legs begin to ache or your patience runs out. Even when health guides suggest that walking around 5 kilometers in a day is a good target, it is still just within reach of your body's memory. You can imagine that. It is a long walk, but not a mythic one. You know what it feels like to carry your weight across that span. Your nervous system has a physical story for it. Beyond that, things start to blur. If I told you about a city that stretches 50 kilometers from one side to the other, your mind might respond by placing a simple tag on it. Big. You do not see that city street by street. You compress it into a label. The number is still there, but it has turned into a symbol instead of a sensation. There is a quiet reason for this collapse. Minds like ours did not grow up walking between stars. They evolved to solve problems within a very narrow shell of space around a small planet. For almost all of human history, what mattered is whether the river was a morning's walk away or a day's march away, whether the herd was close enough to follow before the weather changed, whether the neighboring village was near enough to trade with or far enough to fear. The Earth itself is larger than any of those concerns. Yet, even it pretends to be understandable. Around the equator, the planet's circumference is about 40,075 kilometers. That sounds like a number meant to impress, but your life unfolds inside a tiny fraction of that ring. You move through a thin corridor of familiar routes, returning to the same doors, the same screens, the same rooms. You do not feel the curve of the world under your feet. You feel only commutes and errands. The mismatch becomes clearer if you stand somewhere flat and open and look toward the horizon. From an average human height, the line where the sky meets the ground is roughly 5 kilometers away. That is as far as you can see before the planet gently turns your view away. Your eyes, your balance, your sense of here are all tuned to this shallow bowl of visibility. Anything beyond that must arrive mediated. Maps, stories, photographs, numbers. So when you hear that sunlight takes about 8 minutes and 20 seconds to reach us from the sun, your mind keeps trying to drag that fact back into the scale of daily life. 8 minutes sounds like a song or a shower or a short walk. It does not feel like a gap between a star and a planet. Yet in that short, ordinary time, light is crossing almost the entire width of the orbit that keeps you warm. The same span you cannot imagine walking. Light covers effortlessly while you wait for your kettle to boil. Notice how your mind cheats to keep itself comfortable. Confronted with distances of millions of kilometers, it quietly stops treating numbers as distances at all. They become badges, indicators of very far, extremely far, unimaginably far. Once a number crosses a certain threshold, your brain does not even try to attach it to lived experience. It just places it in a mental box labeled astronomy and closes the lid. This is not a failure. It is a survival strategy. A nervous system that spent all its energy trying to truly feel astronomical scales would be paralyzed by them. You still need to cross the street, not the interstellar medium. The same mind that recoils from millions and billions is perfectly content estimating the distance to the oncoming car and deciding whether you have time to cross before the traffic light changes. But this strategy comes with a side effect. Because huge numbers are flattened into abstraction, they begin to feel harmless, familiar. You hear them so often that you stop noticing what they represent. Millions of kilometers turns into background noise. Light years becomes a poetic way to say very far. Rather than what it actually is, a strict accounting of separation enforced by the fastest thing that can possibly move. Somewhere inside that disconnect, a more personal realization waits. Your sense of world is built from what can reach you in a reasonable span of time. Places you can visit in a day, people who can call and have their voice arrive almost instantly. Events that can change your life within a short number of sleeps. This is what real tends to mean for a creature like us. Close enough to touch, soon enough to matter. Everything outside that local zone still exists. Of course, but it exists as delayed information, not as shared presence. You believe in distant galaxies the way you believe in distant strangers, on trust, through images and reports. Through symbols and numbers that never quite become tactile. The farther something is, the more it becomes an idea rather than a place. If you pay attention, that realization is quietly unsettling. It means most of the universe is not just far away, it is outside the range where your senses, your reflexes, and even your emotional intuitions were built to operate. You live inside a cognitive bubble whose walls are set not by how curious you are, but by how your ancestors needed to move, eat, and avoid being eaten. And yet, within that bubble, you still carry these gigantic labels. Sun, galaxy, universe. They live alongside bedroom and kitchen and train station, as if they were all part of the same mental neighborhood. Language lets them coexist in a single sentence. Physics does not. This is where numbers start to do something strange. Beyond a certain scale, they no longer help you picture the world. They only show you the outline of your own limits. You can write down the distance to the sun, the size of the earth, the span to the horizon. You can memorize them, test yourself on them. Feel a brief spark of satisfaction when you remember correctly. But that memory is not the distance. It is a small, local pattern in a small, local brain. standing in for something it can never fully feel. If that sounds a little lonely, it is because it is, not in the sense of being abandoned, but in the sense of being confined. You belong to a species that can name scales it cannot inhabit, a consciousness that can conceive of distances that refuse to become familiar, no matter how often you repeat the numbers. And this is only the first crack in the illusion, because if kilometers already fail you at the scale of the sun, the universe will not simply ask you to use bigger numbers. At some point, it will need a different kind of measure entirely, one that admits, from the start, that distance is inseparable from time, and that the separation between here and there is not just large, but delayed. The moment you accept that distance and time are tied together, something quiet shifts in the background of your thinking. Units you grew up trusting start to feel less like tools and more like masks that were never meant to be worn this far from home. The kilometer is one of those masks. It was never designed for a universe on Earth. The kilometer behaves well. 1 kilometer is just 1,000 meters, and each meter is 100 centimeters. Each centimeter a small stack of millimeters. In a single step, your body can cover roughly a little less than 1 meter. You can imagine 100 of those steps. You can imagine 1,000. The unit fits your legs. It respects your pace. Even the distance to the moon, on paper, still kneels to the kilometer. The average gap between Earth and its satellite is written as about 384,000 kilometers. You can try to break that apart in your head, thousands of kilometers. Each kilometer sliced into millions of millimeters, each millimeter tiny enough to sit comfortably under a fingernail. The scaling feels tidy, ordered, as if, with enough patience, you could stack reality grain by grain. But that feeling is a kind of politeness. The universe is allowing you, for a brief stretch, to pretend that your unit still means what it meant when it was measuring roads and rivers. Now move outward to the sun. The average distance from Earth to that familiar star is about 149,600,000 kilometers, a span we call 1 astronomical unit. The same unit that once measured your walk to school is now stretched across a gulf where light itself needs minutes to cross. You can still say kilometers with the same calm tone, but the word has slipped away from anything a human body can test. Push farther. The planet Neptune orbits the Sun at an average distance of around 4,500,000,000 kilometers, which is roughly 30 astronomical units. The kilometer is still technically in use here. Mathematically, nothing is wrong. Conceptually, something has already broken. You no longer carry a feeling of how far in your chest. You are just reciting symbols, like a spell in a language you have never heard spoken aloud. This is the point where kilometers begin to die, not as a unit in physics, but as a bridge to understanding. The human mind quietly switches strategies. Instead of asking, "How far is that?" Really? It starts asking, "How impressive does this sound?" Numbers become theater. The unit survives in textbooks, but loses its grip on intuition. You can see this collapse if you try to imagine distances as stacks. Picture 1 kilometer as a row of small, identical blocks you could, in principle, walk along. Now imagine 1,000 of those rows laid end to end, 1,000,000 meters, still barely manageable with effort. But when you climb into the realm of millions upon millions of kilometers, your imagination does not scale with the math. It simply gives up and writes the word vast over the whole scene. The failure is not in the unit. The failure is in the assumption that a unit invented for a small, terrestrial life should remain meaningful as we drag it into places our bodies will never go. The Earth, for example, is orbiting the Sun at a distance that feels enormous in kilometers, and yet tiny when you compare it to the architecture of the solar system. Your entire life, every decision, Every memory, all of human history, has unfolded within less than a single astronomical unit of space. You have never personally crossed even a fraction of that. Your world is narrow, even while your thoughts pretend to roam. Then there is Proxima Centauri, the nearest star beyond the Sun, sitting at a distance of about 4.2 light-years. We will talk more about light-years themselves later, but if you insist, for a moment, on expressing that separation in kilometers, you can. 1 light-year is approximately 9.46 trillion kilometers. Multiply that by a little over 4, and you get a distance on the order of nearly 40 trillion kilometers between us and our closest stellar neighbor. At this stage, the kilometer is no longer a human measure. It is a fossil of a scale we have already left behind. You can keep adding zeros in the privacy of your calculator, but your nervous system does not update. It does not suddenly awaken and declare, "Now I feel it." The only thing that truly grows is the gap between what you can say and what you can inhabit. Somewhere in that gap, a more intimate truth hides. Measurements are not just descriptions of the world. They are quiet statements about where a creature like you fits inside it. A kilometer, a meter, a step. All of them carry the assumption that you might, if circumstances allowed, cross the distance yourself. They whisper, "This is a place you could stand." 1 trillion kilometers does not whisper that. It does not even speak to you. It speaks to the universe about itself. That is why the analogy so many astronomers use feels so sharp. Measuring the distance to nearby stars in kilometers is like measuring the distance between continents in millimeters. It is not that the numbers are wrong. It is that they have lost their purpose. The unit is formally correct, but humanly useless. You can sense this erosion of meaning in language as well. When someone says, "It is light years away," they are usually not thinking about light or years. They are using an astronomical unit as a metaphor for emotional inaccessibility, for the feeling that something is completely out of reach. The science has slipped into the background, leaving only the psychological residue, too far to matter to me. Do 91 to the replies, there is a strange honesty in that mistake. It hints at what is really going on. Once distances exceed what a human life can navigate, the world divides itself into 2 domains. There is the nearby, where cause and effect still feel personal, and the unreachable, where numbers grow. But your sense of involvement does not. The kilometer is a citizen of the first domain. It is an imposter in the second. Even within the solar system, this division is already visible. The distance to the moon, hundreds of thousands of kilometers, is just at the edge of what we can turn into a story of travel, landing, exploration. The distance to Neptune, billions of kilometers away, turns into a story of orbiters we will never ride, and vistas we will only ever see as transmitted images. The unit did not change. The kind of relationship did. You can think of it this way. A unit of distance is also a unit of potential contact. If you can traverse it, slowly, painfully, at great cost, it still belongs to your world. If you cannot, then the number is a boundary, not a bridge. At tens of kilometers, the world is still a place you might walk across. At millions of kilometers, the world has already decided how far you are allowed to go. From here, the light year begins to make a different kind of sense. It is not just a convenience to avoid writing out long strings of zeros. It is a quiet admission that distances on these scales are governed not by human legs or engines or ambitions, but by the finite speed of light itself. When we say Proxima Centauri is around 4.2 light-years away, we are not merely compressing trillions of kilometers into a shorter phrase. We are acknowledging that any influence, any message, any attempt at contact must spend years just to cross the gap. In that context, the kilometer feels like an old habit we have outgrown. It still works here, in the shadow of our own planet, where horizons are a few kilometers away and the moon is a number we can write on a classroom wall. It fails quietly out there, where the smallest meaningful distances are already larger than anything a human life can experience. So the story of measurement is not only about better rulers and finer scales, it is also about learning when to let a unit go. When to admit that the thing you are trying to describe is no longer a place you could ever hope to stand, and that your role, from now on, will be to observe from afar, translating separation into symbols, knowing that the symbols will always feel smaller than what they represent. The moment you realize that a unit can fail, you start to wonder what else in your picture of the universe is just a convenient story. And then you arrive at the quietest, most misleading story of all, the light year. The name itself plays a trick on you. You hear the word year, and your mind rushes to calendars, birthdays, school terms, project deadlines. A year is the rhythm of your life. The time it takes Earth to circle the sun once. It is holidays, weather cycles, the slow aging of faces in old photographs. So when someone says light year, a part of you automatically files it under time. It feels like a kind of cosmic year, a bigger year, a more dramatic year. But a light year is not time. It is distance. It is the space that light crosses while 1 year ticks past on the clock. In a vacuum, light travels at a speed of about 299,792 kilometers per second. That number is not a record set by some particularly successful machine. It is a constant built into the structure of reality. No signal, no object with mass, no information can move faster than that. The universe does not negotiate on this point. If you let that speed run for 1 full year, with all of its days and nights and seasons, the distance that light covers is what we call 1 light year. That comes out to roughly 9,460,000,000,000 kilometers. You can, if you like, imagine every kilometer as a potential step. You will never live long enough to take them. So, when an astronomer says that a galaxy is millions of light years away, they are not describing how long it exists, or how long it will take you to get there. They are telling you how far even light must travel to cross the gap. They are saying, very calmly, that the separation between here and there is measured in entire human lifetimes, stacked end to end. The misunderstanding is subtle but dangerous because it shapes how you imagine your relationship to the rest of the cosmos. If you hear light year and think time, it feels as if distance could somehow be weighted out, as if separation were just a matter of patience. Stay alive long enough, endure enough years, and perhaps the faraway will become reachable. But the light year is not promising you a delay you can outlast. It is telling you that even the fastest messenger in existence must commit a fixed amount of time to every stretch of space. It is telling you that between you and almost everything you see in the night sky, there is a delay that no effort, no courage, no technology can reduce below a certain minimum. There is also a deeper complication hiding in the background. In everyday life, you treat time as something shared. You and a friend can look at a clock, agree that it is late, and go home. Now feels like a universal slice of reality that everyone occupies together. Over the kinds of distances your life usually involves, this works well enough. Once light years enter the story, now starts to fracture. If a star 4 light years away were to explode in this instant, you would not see it for another 4 years. For you, the explosion would still be in the future. For anything happening near that star, it would already be over. The light year is a measure of how out of sync different parts of the universe are allowed to be. This is what it really means to say that a light year is distance, not time. It is not a waiting period. It is the size of the gap between 2 events that cannot influence each other any faster than light can run. Even familiar examples look different when you see them this way. When you look at the sun, you are seeing it as it was around 8 minutes ago. The light that touches your eyes left that glowing surface several minutes before you glanced up. If the sun were to vanish at this moment, the sky would still appear normal for those 8 minutes or so. For a brief while, the Earth would be orbiting a star that no longer exists, and there would be no way to know. That delay is only a handful of minutes, but it hints at a more general rule. The farther away something is, the more of its past you are forced to live with. Distance in light years tells you how far into the past you must reach every time you look up. This is not just a poetic idea. It is the foundation of observational astronomy. When telescopes capture the feeble glow of distant galaxies, they are seeing those galaxies as they were millions or even billions of years ago, because that is how long their light has been crossing the void. A light year makes the connection precise. 1 year of history per light year of distance, paid out in irreversible delay. Notice how this twists the usual meaning of closeness. Here on Earth, to be close to someone is to share roughly the same present. You can speak and be heard almost instantly. You can reach out and touch. Your reactions are tuned to the same events happening around you. Closeness is synchronized time. On cosmic scales, that kind of closeness barely exists. The light year exposes how thin the layer of shared present really is. Beyond a small local bubble around you, everything you see and everything that might see you are trapped in each other's pasts. You do not share a common now. You exchange delayed evidence that each of you once existed. This is where the existential weight of the light year starts to show. It is not just a large number. It is a measure of how alone any point in the universe is allowed to be. A planet 10 light years away cannot know what is happening here until 10 years after the fact. If some civilization lives there and listens carefully, its picture of Earth is always at least a decade out of date. Your most urgent crises, your quietest joys, your entire sense of what today means, arrive to them as old news. The same is true in the other direction. If they send a signal, it will take 10 years to reach you. A simple exchange of questions and answers takes 20 years. 2 short sentences, and 2 decades of waiting in between. By the time you respond, the person who asked might be gone. Their world might have changed beyond recognition. The conversation continues, but the participants do not. Understanding that a light year is distance makes this clear. It strips away the illusion that the universe is a single conversation happening in real time. It shows you that most interactions are more like letters sent between strangers who will never meet, delivered across gulfs so large that both author and reader may be gone by the time each message arrives. Yet there is a strange kind of honesty in this arrangement. It forces meaning to be local, your choices, your relationships, your small circle of shared present, all unfold inside a region where light can cross quickly enough to keep you in touch. Beyond that region, the universe continues without you, and you continue without it. Not because of negligence or indifference, but because the speed of light quietly says, "This is as connected as you are allowed to be. Today, I was others." The phrase light year can hide that truth when you treat it as time. Time suggests you could simply wait it out, that enough years might close the gap. Distance, especially distance measured by the fastest thing that exists, tells you otherwise. There is no shortcut, no hidden path, no secret corridor through which information can sneak. The delay is not a flaw in your technology. It is a rule of the game. Once you see it this way, the night sky changes character. Those points of light are not just far away in space. They are far away in time in a way that is perfectly quantifiable. Each star is not only located somewhere out there, it is also located some number of years behind your present. The light year stitches those two facts together into a single measure. And in that stitched fabric, you can see yourself more clearly. You are a small arrangement of matter and thought, living for a brief span, moving at slow speeds along the surface of a planet. Your entire lifetime is only a tiny fraction of a single light year when measured as a journey at the speed of light. You will never cross even that 1 unit in person. For you, every light year is not just a distance you will not travel. It is a distance where you're present and the universe is present, never quite touch. Strangely, there is comfort in recognizing this. It means you are not failing by staying here. You are not missing some vast party happening just out of reach. The structure of space and time simply does not permit the kind of closeness your imagination casually assumes. The light year is the universe's way of saying, this is how far presence can stretch before it turns into memory. And that quiet correction, repeated every time you hear the word, is what makes misunderstanding the light year so consequential. If you keep treating it as time, you can keep believing that the universe is late, but on its way. If you accept it as distance, you realize that most of what exists will never arrive. It will only ever send light, always delayed, always from a version of itself that has already moved on. So if most of what exists can only ever arrive late, it makes sense to look more closely at the messenger itself, the thing racing between all these separated places and never quite catching up. Light feels instant. When you flick a switch in your room, the bulb responds so quickly that your senses blur cause and effect into a single event. When you make a video call across an ocean, the other person's voice reaches you with so little delay that it feels like a shared room. Your brain quietly upgrades light from fast to immediate. And once that upgrade is installed, it is very hard to remove. In reality, light is fast in a way that does not belong to human experience at all. In a vacuum, its speed is exactly 299,792,458 meters per second, a value woven into the definitions of our units themselves. You can say that number out loud, you can write it down, but you cannot feel it. It does not correspond to anything your body has ever done. To make it friendlier, people often say about 300,000 kilometers per second. That is roughly the distance from one city to another, repeated hundreds of times in the span of a heartbeat. Even that softened description does not fully land. You have never seen anything cross a continent in a fraction of a second. So your mind quietly files 300,000 in the same abstract drawer as all the other giant numbers. Impressive, but not inhabited. One way to get closer is to fold that speed around the planet you stand on, measured around the equator. Earth's circumference is about 40,000 kilometers. At light speed, a signal could circle that distance in well under a single second. Light could, in principle, lap the world more than 7 times in the time it takes you to blink, once in surprise at that fact. On this scale, the speed of light behaves like a magic trick. It shrinks the largest distances on your planet into almost nothing. Messages can cross oceans in what feels like an instant. Global events seem to happen in a shared present because the delay between them is shorter than the resolution of your attention. For all practical purposes, the speed of light is infinite, inside the thin shell of space where human lives unfold. That illusion is part of why the speed of light is so badly misunderstood. In everyday life, it behaves like a kindness, smoothing out the gaps between here and elsewhere until you forget that the gaps exist. Underneath that kindness, though, there is a hard rule. Even this unimaginable speed is finite, and finiteness, when stretched over cosmic distance, becomes delay. You can see both sides of this if you step just a little beyond Earth. The average distance between Earth and the Moon is around 384,000 kilometers. At light speed, that gap takes about 1.3 seconds to cross. On the one hand, that is astonishingly quick, a beam of light, or a radio signal, covering hundreds of thousands of kilometers in the time it takes you to inhale slowly. On the other hand, the delay is large enough that you can hear it in the recordings of conversations between astronauts and mission control. Voices step on each other. Questions and answers feel slightly misaligned, like people talking from opposite ends of a long hallway. That small lag is the speed of light made audible. It is what happens when the universe stops hiding its finite nature from you. Stretch the distance further. The average gap between Earth and the Sun is about 149,600,000 kilometers. And light takes about 8 minutes and a little over 10 seconds to make that journey. Again, the scale splits your intuition in two. 8 minutes is a coffee break, a short wait at a bus stop, a restless scroll through messages on your phone. Yet, in that gentle span of time, light is racing across an orbit so vast that no plane, no rocket, no human expedition has ever come close to matching it. This is the pattern the speed of light forces on you, absurdly fast when compared to anything you can build, and yet unavoidably slow when compared to the distances that matter beyond your small planetary neighborhood. It is both too fast for your perception and too slow for your ambitions. Another common misunderstanding grows out of that contradiction, because light outruns every other messenger you know. You might assume that if only you could somehow catch up, you would unlock a new kind of freedom. Go faster than light, the fantasy says, and you could outrun delay itself. You could see events as they happen, talk across the galaxy in real time, travel without leaving anyone behind. Physics does not allow that escape. Modern experiments confirm that nothing carrying information or mass can exceed the speed of light in a vacuum. The constant, often written as c, is not just a really large number. It is a ceiling written into the structure of space-time. You can approach it, in equations and in thought experiments, but you cannot cross it. Once you accept this, the speed of light stops looking like a tool and starts looking like a boundary. It defines which events can possibly influence which others, and in what order. It decides which points in the universe can ever be in meaningful conversation, and which are locked out of each other's present forever. The number itself fades, but the consequences remain. There is an uncomfortable intimacy in that realization. It means that even if you filled the galaxy with radios and lasers and data streams, every message would still crawl along at the same ultimate pace. Two worlds separated by 10 light years could share recordings, mathematics, stories, but never a shared now. The speed of light would always stand between them, turning every interaction into an exchange of memories. Here, the existential undertone becomes hard to ignore. You live your life as if the present were a universal stage, as if everyone and everything that exists is somehow coexisting with you in a single, continuous moment. The speed of light quietly contradicts that picture. It says that your present is a local phenomenon, a small region of space-time within which signals can bounce around quickly enough to keep you and the people near you loosely in sync. Beyond that region lies a patchwork of other presents, each defined by the same limit, each unaware of the immediate details of the others. The universe is not one shared moment stretched over a vast distance. It is many separate nows, overlapping imperfectly, stitched together by light that is always running slightly behind. What makes this so difficult for the human mind is that you almost never experience the limit directly. The devices in your pocket, the cables under the ocean, the satellites overhead, all of them work so close to instant that your senses happily round the delay down to zero. You move through a world where distant actions seem to update everywhere at once. News spreads, markets move, messages arrive. It feels like a single global room. But that feeling is a local illusion, built on relatively small distances and the extraordinary speed of your messenger. It holds as long as the signals you care about only need fractions of a second to reach you. Once the geometry of space demands seconds, minutes, hours, years, the illusion frays. The same speed that once made the world feel small now reveals how large and how disconnected it really is. In a way, the speed of light exposes a quiet tension at the heart of being a conscious creature in a vast universe. Your thoughts are fast compared to your body. Your signals across a planet are fast compared to your history. But compared to the scale of galaxies and clusters and the full observable cosmos, everything about you is slow. Your desires for connection, for real-time understanding, for shared experience across distance, all of them run up against a constant that does not care what you want. And yet, this is not simply a story of limitation. The same finite speed that keeps you out of sync with distant stars also lets you see them as they were long ago. Each photon arriving at your eye is a record of a journey, a small piece of the past delivered to the present at exactly the pace the universe allows. The delay that isolates you is the same delay that turns the night sky into a kind of archive. The human mind was not designed for this. It was shaped to track moving animals, shifting shadows, changing faces across meters and seconds. Asking it to internalize hundreds of thousands of kilometers per second, or light minutes, or light years, is asking it to leave its native scale. No amount of repetition will make that speed feel ordinary. Maybe that is the real misunderstanding. The speed of light is not just too fast for you to easily imagine. It is a reminder that your imagination itself is a local tool, tuned to a narrow band of distances and durations. Outside that band, reality continues with or without your intuition's permission. Light keeps racing, slowly revealing a universe where everything that could be close is only close for a while, and everything else remains forever, just a little bit out of reach. The idea that nothing can cross space faster than light sounds abstract until you watch the universe arrive late, again and again, and realize that delay is not an accident but a rule. For a long time, people assumed light was instantaneous. How could it be otherwise? Lightning splits the sky and the flash and the thunder feel almost like a single event. A candle across a dark room appears the moment it is lit. Even the sun seems steady and immediate. There was no obvious reason to suspect that light was running a race it could ever lose. When scientists did begin to ask whether light had a finite speed, their first attempts were almost endearingly local. Lantern experiments across hills, mirrors a few kilometers apart. Human reaction times trying to compete with a messenger that can lap the Earth in less than a heartbeat. Those efforts failed not because the question was wrong, but because the stage was too small. The delay existed, but it was drowned in the noise of human slowness. The solution, when it came, did not involve bigger lanterns. It involved a bigger clock. In the late 17th century, the Danish astronomer Ole Rømer was working at the observatory in Paris. Above him, the planet Jupiter carried its moons in steady, predictable orbits. One of those moons, Io, circles Jupiter roughly once every 2 days. Each time Io passes behind Jupiter and slips into its shadow, it disappears, then reappears, like a lighthouse rhythm written into the sky. To Rømer, those eclipses were not just pretty events, they were ticks of a distant clock. In principle, each one should arrive exactly one orbital period after the last. If you know when one eclipse happens, you can predict when the next should occur, and the next, and the next, many cycles into the future. The geometry of the orbit does not care what is happening on Earth. But when Rømer compared his predictions to his observations over many months, something strange appeared. Sometimes Io's eclipses seemed to happen earlier than expected. Sometimes they were late. The differences were not random. They followed a pattern that rose and fell over roughly half an Earth year as our planet moved along its own orbit. When Earth was on the same side of the Sun as Jupiter, the eclipses seemed to come slightly too soon. When Earth was on the far side of its orbit, with the Sun in between, the eclipses arrived late. The total difference between the shortest interval and the longest was about 22 minutes. If light were truly instantaneous, this made no sense. Io was still orbiting Jupiter at the same pace. Jupiter itself was following a smooth, predictable path around the Sun. Nothing in the mechanics of the system was speeding up or slowing down by tens of minutes. Yet the clock in the sky seemed to stretch and compress its own ticks, depending on where Earth was. Rømer made a different assumption. He imagined that the events at Jupiter, the actual moments when Io entered or left the shadow, were perfectly regular. What was changing was the travel time of the light, carrying news of those events to Earth. When our planet was moving away from Jupiter, that light had farther to go. So each tick of the clock reached us a little later. When we were moving toward Jupiter, the distance shrank, and the ticks arrived sooner. From this, he concluded that light must have a finite speed. There was no need for the moons of Jupiter to misbehave. The delay was not in them, it was in the messenger crossing the widening or narrowing gap. Using his estimate of how large Earth's orbit was, Rømer worked out that light took on the order of 22 minutes to cross the diameter of that orbit. From that guess, others, like Christian Huygens, could compute an approximate speed, enormous, but not infinite. The exact numbers were off by modern standards because the size of the orbit was not yet well known. But the essential point was clear. Light did not jump instantly from place to place. It traveled. And travel meant time. This was the birth of cosmic delay as a measurable fact, not just a philosophical worry. Notice how subtle the shift is. Before Rømer, you could look up at Jupiter and think, in a loose way, that you and that planet existed in the same moment. After his work, that picture was no longer tenable. Every eclipse of Io you could possibly observe had already happened by the time its light reached your telescope. The universe you see is not the universe as it is, but as it was, filtered through the finite speed of its own signals. The scale here is almost modest compared to the depths of space. The extra distance light had to travel, when Earth was on the far side of its orbit from Jupiter, was about 2 astronomical units, the diameter of Earth's orbit around the Sun. 1 astronomical unit is defined to be roughly the mean distance between Earth and the Sun, about 149,600,000 kilometers. 2 of those units are enough to stretch a simple eclipse pattern by minutes. If such a small change in distance can reshape the timing of a clock on the far side of the solar system, it is easier to imagine what happens when the distances grow to light years. Rømer's discovery also quietly undermined something deeper than a unit of speed. It undermined the instinct that events in the universe line up neatly along a single, universal now. If different observers are separated by large distances, signals linking them will always carry the past from one side to the other. There is no way to coordinate clocks that does not bake in the delay. The proof did not arrive as a sweeping manifesto. It arrived as small discrepancies in a notebook, predicted times, observed times, minute after minute of stubborn mismatch. That is often how limits show themselves. Not as walls you crash into, but as tiny, repeated corrections to your expectations until your old picture of the world can no longer stand. Later astronomers refined Rømer's work. James Bradley used the aberration of starlight to provide another, independent measure of the speed of light. Laboratory experiments by people like Hippolyte Fizeau and Léon Foucault bounced light between mirrors and measured its travel time more directly. Each new method narrowed the uncertainty. All converged on the same conclusion: a finite, fixed speed, the same in every direction, the same for all observers. By the time Einstein built special relativity, the finite speed of light was no longer a curious detail. It was the structural beam holding the theory together. But the emotional shock of that finiteness had already happened. In a sense, the first time someone realized that the universe was late. If you listen closely, that realization reaches into the small scale of ordinary life as well. When you look at someone's face across a room, the light carrying their expression has taken a tiny fraction of a second to arrive. The delay is too small to matter. But it is not zero. When you look at the moon, you see it as it was about a second and a bit ago, because the average Earth-Moon distance is on the order of hundreds of thousands of kilometers. and light takes that long to cross it. Most of the time, you ignore this, and rightly so. Life depends on treating near things as effectively simultaneous. But once you know the rule, you cannot quite unsee it. Every glance, every observation, is a meeting with something that has already moved on from the state in which you are seeing it. Presence, even here, is slightly out of date. That might feel unsettling, but it also explains why meaning tends to form in small circles. The people and places that matter most to you are the ones inside a zone where light and sound and touch can exchange signals quickly enough that you can still call it together. Rømer's distant clock on Io showed that beyond that zone, even the simplest pattern phrase under delay, the night sky, then, is not a shared ceiling under which everything happens at once. It is a time map, each dot placed at a different depth of the past, each beam of light carrying its own travel time. The first proof that light is finite turned that from metaphor into measurement. From here on, whenever you hear that light has a speed, you can think of more than a large number with many zeros. You can remember a moon circling Jupiter, its eclipses drifting by minutes because Earth and Jupiter have shifted their positions. You can remember that this was the moment humanity stopped living, even in imagination, in an instantaneous universe. And you can carry forward the softer consequence. That delay is not an error in the system. It is the system. Every connection is built on it. Every glimpse of the cosmos is late. The light that feels so fast in your daily life is, on the scales that define the universe, slow enough to let separation accumulate. 1 minute, 1 hour, 1 year at a time. The first time you realize that every sight is already late. It can feel as if the universe has quietly stretched away from you. Then you meet a word that finishes the job, not with philosophy, but with arithmetic, trillion. At small scales, numbers behave like old friends. 1, 2, 10, 20. You can count them on your fingers, on your steps, on the things you own. 100 might be the number of people in a room, or pages in a book. 1,000 could be the number of songs in a playlist, or the distance in meters to somewhere you have actually walked. Each of these has a texture. Your body remembers them. 1,000,000 already sits at the edge of that comfort. You can say a city of 1,000,000 people, and you know cities, crowds, traffic. You have stood in packed streets and busy stations. The number resonates. Even if you cannot trace it face by face, it still feels like a quantity made of individuals, not just a label. Then the words continue. Billion, trillion. The syllables are easy. The meaning is not. Somewhere along that climb, the numbers stop behaving like distances or counts and turn into something else. Icons of vastness. You do not imagine each unit. You cannot. Your mind blurs them into a single impression. Too many. Too large. Too far. There is a simple way to feel where this break happens. Imagine that you decide to count, steadily. 1 number every second. No pauses. No sleep. No breaks. Just a voice and a clock. If you kept that up for 1,000,000 seconds, you would be counting for a little more than 11.5 days. 11 days is long, but it is still a story your body can tell. You can imagine being tired, losing track of time, but you can put it on the same shelf as long trips, difficult projects, strange weeks that seem to stretch on forever. Now extend the thought. 1,000,000,000 seconds, counted one by one, would last for a little more than 31 years. Suddenly the number reaches across an entire adult life. Childhood, school, work, relationships, mistakes, recoveries. If you started counting at birth and never stopped, you would barely finish that billion by the time you reached middle age. The number has crossed from something you could suffer through to something that could quietly replace your whole life. A trillion seconds lives on a different plane entirely. 1 trillion seconds at 1 count per second is roughly 31,688 years. That span goes back long before any recorded history. Deep into a time when there were no cities, no writing, no telescopes, no names for the stars. A trillion seconds is not just more time than you have, it is more time than your entire culture can remember in detail. This is what it means for a number to break intuition. You can say trillion as easily as you say 10, but there is no lived experience to attach it to. Your nervous system has no way to rehearse 31,000 years. The number enters your mind as a shape of sound, bounces off a few familiar comparisons, and then leaves you standing in front of a blank wall. Distances behave the same way. Earlier, we treated kilometers as if they were cooperative. A kilometer is a walkable thing. 10 kilometers is a long walk or a short drive. 1,000 kilometers is a trip that still lives in the human world. Trains, planes, road maps. 1,000,000 kilometers begins to strain that logic. But you can still say, that is many times around the world, and feel a faint echo of it. Now bind that fragile unit to light. 1 light year, the distance light travels in 1 year in a vacuum, is about 9,460,000,000,000 kilometers. 9 trillion kilometers is not just a big number. It is a statement that even at the fastest possible speed, crossing that distance takes a full year of relentless motion. When you say a nearby star is 4 light years away, you are casually invoking tens of trillions of kilometers. The kilometer has become a mere syllable in a sentence that no longer cares what your legs once did. Another way to see the fracture is to stack something small. A standard sheet of copy paper is roughly 1/10 of a millimeter thick. Stack 10 sheets, and you get about 1 millimeter. Stack 100, and you have a pile you can pinch between 2 fingers. This is still a world you know. Now imagine stacking 1 trillion sheets of that same paper. Multiply that tiny thickness by that huge count. The resulting tower would rise to around 100,000 kilometers. That is a column of paper reaching roughly a quarter of the way from Earth to the Moon, whose average distance from us is about 384,400 kilometers. A thing as ordinary as printer paper, repeated enough times, becomes almost planetary in scale. No one will ever build that tower, of course. The point is not practicality. The point is that your intuition is perfectly happy to handle 10 sheets, 100 sheets, even 1,000, somewhere long before you reach a trillion. The picture dissolves. The stack stops being a thing you can imagine and becomes a trick of language. Notice how, in each of these examples, the step from thousands to millions hurts a little, but you can adjust. The step from millions to billions feels strange, but you can patch it with analogies, years of life, city populations, national budgets. The step from billions to trillions does something different. It does not just stretch your sense of magnitude. It breaks the link between number and experience. This matters because the universe spends most of its time in the realm of trillions and beyond. The age of the Earth is estimated at around 4.5 billion years. The distances we use light years to describe are counted in trillions of kilometers. The number of stars in a galaxy, the number of galaxies in the observable universe, the amount of time since the first light crossed the cosmos, almost all of it lives far beyond the point where your counting stories can follow. When you try to drag your daily instincts into this domain, you end up with comforting distortions. Trillions becomes a word you might hear in news about economics, or in hyperbole about trillions of stars, and your brain quietly reacts with a shrug. A lot. The specific meaning, the exact, brutal scale of it, never really lands. That vagueness is a defense mechanism. If every trillion carried its true weight in your thoughts, moving through the day would be exhausting. Yet the numbers are not going away. They are how the universe writes its own autobiography. Every light year of distance is roughly 9.5 trillion kilometers of empty space, threaded with a few particles and fields. Every trillion seconds of cosmic history marks an era in which entire species appeared and vanished. When astronomers say trillion, they are not exaggerating. They are being modest. There is a quieter consequence to this mismatch between number and intuition. It tells you something about where meaning can realistically take root. Your life fits into less than 100 years. Call it a little more than 3 billion seconds if you like. Though even that is another number that barely fits in the mind. Most of what you will ever touch, understand, love, or fear will unfold within a tiny fraction of a single trillion seconds, in a tiny patch of space, a few light hours wide at most. Beyond that, time and distance still exist. But they do so without you. They accrue their trillions silently. Stars orbit, galaxies merge, dark matter flows, and the numbers that describe those processes grow ever larger. You can calculate them, you can write them down, print them in textbooks, model them on supercomputers, but they will never feel as real as the distance between your room and your door, or the hours in a difficult night. Instead of treating that as a failure, you can read it as a kind of boundary condition on being human. There is a scale at which you were built to care. The scale of friends, streets, clouds, weather, maybe planets if you are particularly imaginative. Above that, you are an observer, not a participant. The number trillion marks one of the edges of that transition. It is where arithmetic keeps going, but your instinct stops. This edge becomes especially important when we talk about light years. As long as those distances are expressed in trillions of kilometers, they will remain mostly symbolic for you. You will nod, perhaps feel a brief shiver of awe, and then your mind will quietly place them in the same category as every other enormous statistic. Impressive, abstract. Elsewhere, what we are really trying to get at is not just how big those numbers are, but what they do to the idea of connection. A trillion seconds is long enough for whole civilizations to rise and fall. A trillion kilometers is enough to ensure that even light, racing as fast as the universe allows, arrives late by years. The number itself becomes a kind of wall, not a wall of matter, but a wall of delay. When you stand under the night sky and hear someone say, "That galaxy is tens of millions of light years away," you are listening to a sentence that contains layer upon layer of this broken intuition. Millions, trillions, light years, all stacked together. Your senses cannot follow. They were never meant to. All they can really know is that, somewhere beyond the reach of your own lifetime, the numbers have escaped. In that sense, trillion is more than a quantity. It is the point at which the universe stops pretending to be sized for creatures like us. It is the threshold where counting turns into confession. We can describe what lies beyond this, but we will never fully feel it. From here on, if we want any grip at all, we have to change how we measure, not to make the universe smaller, but to admit openly how far away it really is. When numbers stretch past the point of feeling, the only way forward is not to climb higher, but to step sideways to find a scale that speaks in something closer to experience. That is what happens when distance starts borrowing the language of light itself. Start small. Imagine a light second. A light second is the distance light travels in 1 second, racing through empty space at about 300,000 kilometers per second. You have never seen anything move that fast, but you have felt a second. You know how long it takes your heart to beat twice, how long a breath can hover between in and out. Now, inside that tiny slice of time, imagine enough distance for light to wrap around the Earth more than 7 times. 1 second, 7 world-circling laps. That is 1 light second. Already there is a misunderstanding waiting, because light seconds are so small compared to light years. They sound harmless, almost cute, like a child's version of a grown-up unit. In everyday speech, a second is what you waste. What you just need a few more of before you leave the house. But a light second is not a disposable thing. It is a measure of how far reality can fall out of sync in the time it takes you to blink. The Earth-Moon distance shows this clearly. On average, the Moon orbits roughly 384,000 kilometers away. That gap is large enough that you could line up the entire Earth more than 30 times between the two. Light takes about 1 1/3 seconds to cross it. For your nervous system, 1 second is almost nothing. For a radio signal, it is a real journey. When the Apollo astronauts spoke from the lunar surface, each sentence had to cross that gulf and then return. Question goes out. 1 and a bit seconds. Answer comes back. 1 and a bit seconds. The conversation is shifted. Everything's slightly off the beat. You can hear that offset in old recordings. Voices pile up. Pause. Correct. It is not dramatic. Not the stuff of science fiction delays where you wait hours for a reply. But it is just large enough to be felt. That small, stubborn lag is a light, second made audible. It is the universe reminding you that even nearby worlds are not truly sharing the same instant with you. Now imagine shrinking even further. The distance between you and another person across a room is maybe a few meters, a fraction of a light microsecond. The time it takes their reflected light to reach your eyes is so small that your brain treats it as zero. Here, light seconds do not enter the story at all. You live inside what feels like perfect simultaneity, a pocket where cause and effect line up neatly and feedback is immediate. This is the scale on which your sense of now was built. The trouble begins when you try to drag that feeling outward, move from light seconds to light minutes. 1 light minute is simply 60 light seconds placed end to end. In that time, light travels about 18 million kilometers. You have never moved that far, and neither has any human machine. But the unit is still grounded in something you know, a minute. The time it takes for water to just begin to boil. The length of a short song. The patience you can maintain while an elevator is slow. The sun sits a little over 8 light minutes away from Earth. That means every time you look at it through proper protection, if you are wise, you are seeing it as it was more than 8 minutes ago. In those 8 minutes, the light has threaded its way across roughly 149,600,000 kilometers of space, carrying with it the last report of the sun's surface. If, in some impossible instant, the sun were to vanish, the sky above you would look unchanged for those 8 minutes. The delay is baked in. Most people know this fact in a casual way. They may have heard it in a documentary, or seen it as a trivia line. Sunlight takes about 8 minutes to reach us. The misunderstanding is not in the number, but in how it sits in the mind. 8 minutes sounds small. It is less time than a break at work, less time than a commute between stations. It feels like an inconvenience, not a structural feature of reality. So the mind nods and moves on. But 8 light minutes is not an inconvenience. It is a radius of unavoidable ignorance. For 8 minutes, whatever the sun is actually doing is sealed off from you. Your planet continues on the basis of old information, trusting that nothing catastrophic has happened in the meantime. So does every plant, every animal, every cell that relies on that steady stream of photons. Life on Earth is always 8 minutes behind its star. Once you let that sink in, light minutes start to become something you can feel, not just recite. They are the glue holding together a small bubble of mutual awareness. Within a light second or two, you can speak and be heard, see and be seen, act and be answered. Within a few light minutes, you can still coordinate, navigate, maintain a fragile sense of shared time. Beyond that, things start to unravel. Even inside the solar system, Engineers run up against this boundary. Signals to Mars, depending on the positions in orbit, can take anywhere from a handful of light minutes to nearly half an hour. By the time a command leaves Earth, crosses tens of millions of kilometers, reaches a rover, and a response comes back, the situation on the ground may already have changed. There is no such thing as a joystick for Mars. There is only careful planning and accepting that the light minutes in between enforce autonomy. You do not need to know the exact figures to understand the pattern. Light seconds and light minutes are not just larger versions of the time you measure on your watch. They are the sizes of gaps beyond which your usual sense of connection no longer works. They mark the transition from interactive to observational, from conversation to correspondence. There is a quiet existential angle to this that hides under the technical language. Your sense of self is stitched together by feedback, arriving almost immediately. You speak. You hear your own voice. You move. You feel muscles respond. You send a message. You see the reply pop up within seconds or minutes. All of this convinces you that you live in a world where action and response are naturally tight. Light seconds and light minutes are how the universe gently corrects that impression. They show you that this tightness is local, a privilege of short distances. Stretch the space between 2 points beyond a few light minutes, and the fabric of shared experience thins. You can still send signals, but you cannot live in the same moment anymore. It is tempting to treat this as a problem to be solved by better technology, faster networks, better compression, more powerful transmitters, and those things help as long as the bottleneck is human engineering. But none of them can make a photon outrun its own speed. No amount of cleverness can reduce 8 light minutes to 3, or 1, or 0. The misunderstanding here is to believe that delay is just a matter of infrastructure, rather than the shape of space-time itself. Building intuition from light seconds to light minutes is, in the end, a way of learning where you actually are. Not at the center of a perfectly synchronized universe, but inside a small, bright pocket where signals can still keep up with your expectations. Beyond that pocket lies a vast territory measured in units that tie distance and time together so tightly that you cannot pull them apart. A territory where far away always means long ago. Well, you do not have to like this. Nothing in you was designed to find comfort in multi-minute delays just to hear back from a nearby planet, much less years of travel for light between stars. But you can at least see it clearly. A light second. A light minute. These are not abstract tricks of physics. They are the smallest rungs on a ladder that leads away from the illusion of a shared cosmic present, toward a quieter truth that almost all of what exists is living its own time, and you only ever meet it after the fact. The moment you accept that almost everything you see is already over, the next question is simple and uncomfortable. How far can you stretch a connection before it stops feeling like a conversation at all? Mars is where that question stops being theoretical. In pictures and headlines, Mars looks close, a neighbor, a place we might visit, settle, even terraform in speculative futures. The word neighboring planet suggests something just beyond the fence. The kind of distance a determined species might cross with enough rockets and enough time. In that story, the space between Earth and Mars is a challenge, not a boundary. But distance does not care about how neighborly something sounds. On average, Mars and Earth are about 225 million kilometers apart. That number is already beyond any roadmap or flight route you have ever seen. Yet the misunderstanding does not lie in the size of the distance. It lies in what that distance does to time. Because both planets orbit the Sun, their separation changes constantly. When they are on the same side of the Sun and relatively close, the gap between them can shrink to a few tens of millions of kilometers. When they swing to opposite sides, it can grow to hundreds of millions over that entire range. Light, The fastest thing that exists needs anywhere from about 3 minutes to more than 20 minutes to cross the Gulf. One way. That means a simple question and answer between Earth and Mars, spoken as radio waves, can easily take half an hour or more. You say, "Turn left." The rover hears you many minutes later. It turns. Its camera sends back an image. You see the result many minutes after that. By the time you react to what has already happened, the rover is somewhere else. This is why no one drives a Mars rover the way you might pilot a drone over a park. There is no joystick, no live video feed you can respond to in real time. Instead, engineers on Earth send carefully prepared sequences of commands, plans for a Martian day. The rover executes them mostly on its own, making small decisions about rocks, slopes, and wheel slips without asking permission for each move. If it waited for advice at every moment, it would barely move at all. The end of real-time control begins here, at light minutes. This is easy to miss if you focus only on distance. You might think, with better rockets, we will travel faster. With better antennas, we will communicate more clearly. Those things help with many problems, but they do not touch the limit that matters most. Even if your technology is perfect, the photon still takes its required minutes to travel between worlds. You cannot negotiate those minutes away. So the misunderstanding is not simply that Mars is far. It is that we keep smuggling our earthbound sense of now into a situation where now no longer exists in the shared way we are used to. When you imagine yourself standing on Mars, talking to someone on Earth, it is natural to picture a long-distance call, a slight delay, but fundamentally the same kind of connection. The reality is closer to exchanging letters with an unpredictable postal service built from the geometry of orbits. There is a quieter, human consequence hidden here. When a rover rolls across Martian dust, it is, in a limited sense, our representative. We build it, name it, cheer for it. We watch images arrive and feel as if we are taking each step with it. But the rover itself never occupies the same moment as the people watching. It lives in a time that is always offset, always lagging or leading by several minutes. The bond between the machine and its makers is stitched through delay. From the rover's point of view, if it had one, the universe would feel lonely in a very specific way. It would act, wait, and then, after a stretch of silence, receive a new batch of instructions based on where it used to be. The present in which it moves and the present in which we plan for it are always out of phase. Mars is not just a different place. It is a different clock. If Mars marks the point where delay takes the steering wheel from your hands, Saturn shows how far that principle can go while still remaining inside a single solar system. Saturn orbits the Sun at an average distance of about 1.4 billion kilometers, roughly 9.5 astronomical units from the Sun. Sunlight takes around 80 minutes to reach it. From Earth, depending on where both planets are in their orbits, the distance to Saturn can also be over 1 billion kilometers. And the light travel time from Saturn to Earth is typically on the order of more than an hour. Think about what that means for a spacecraft in orbit there, like the Cassini mission that studied Saturn and its moons for over a decade. Every command sent from Earth took roughly an hour to arrive. Every piece of data, images of rings, measurements of magnetic fields, glimpses of icy moons took roughly an hour to come back. A single question and answer could easily span most of an afternoon. You cannot fly a spacecraft under those conditions in the way you might imagine from films. You cannot see a rock and dodge it in the same breath. By the time the warning arrives at your console, the event is already part of the past. Cassini, like the Mars rovers, had to be given goals. Not moment-by-moment instructions, its course corrections, observations, and even the sequence of its final plunge into Saturn's atmosphere were all planned long before the signals that triggered them actually arrived. If Mars took away the joystick, Saturn takes away even the illusion that someone is constantly at the controls. It exposes the reality that, past a certain distance, human presence becomes a delayed influence, not a guiding hand. There is something quietly revealing in how we respond to this. Instead of giving up, we design machines that can tolerate the gap. We build autonomy into circuits and software, teach probes to judge whether an image is worth sending, whether a hazard is worth avoiding, whether a signal is strong enough to trust. We hand off decisions to systems that can act inside light seconds instead of light minutes or hours. In doing so, we act out a truth the universe has already written. Beyond a small local zone, everything must decide for itself. If you imagine, for a moment, a human settlement on Mars or a research station in orbit around Saturn, the same rule applies. Even if people live there, even if they talk to Earth every day, their practical reality will be shaped by delays. A crisis on Mars cannot be managed from Earth in real time. A conflict in a Saturnian outpost cannot be resolved by live debate with a committee at home. Advice can arrive, data can arrive, but the moment of action will always belong to the people on the spot. This is not just a logistical constraint. It is a boundary on authority, on responsibility, on the very idea of shared governance across space. Light minutes and light hours quietly erase the fantasy of a single, unified timeline for a civilization spread across planets. Instead, you get clusters of now, each one local, each one separated from the others by gaps measured in minutes and hours of unavoidable ignorance. The old misunderstanding, believing that distance is something technology can always overcome, runs deep here. On Earth, with cables and satellites and high-frequency networks, we have almost convinced ourselves that delay is obsolete. You can watch an event on the far side of the planet with only a fraction of a second between it and you. You can send money, words, images, and see them act almost immediately. It feels natural to extend that expectation outward, as if the universe were just waiting for us to lay down enough infrastructure. Mars and Saturn stand as simple, calm counterarguments. Light takes the time it takes. Between a control room in California and a drone in the next city, that time is negligible. Between that same control room and a rover on Mars, it expands into minutes. Between it and a probe at Saturn, it stretches into hours. No fiber optic cable, no improvement in hardware can shrink those numbers below what geometry and physics allow. So we adapt our stories. Instead of remote control, we talk about mission profiles and autonomous navigation. We accept that signals will arrive late and that some decisions will always be made by someone or something that cannot check with us first. We learn, reluctantly, that to extend our reach into space is also to loosen our grip. There is a small, personal mirror of this in ordinary life. You cannot control the people you care about in real time. Even when they are close, they move, choose, and change in ways that only reach you after the fact. Carried not by photons, but by words, gestures, messages. The farther away they are, the more your influence becomes advice rather than intervention. At planetary scales, light simply makes that structure inescapable and literal. Mars, Saturn, and the distances between them and us are not just entries in an astronomical table. They are examples of where the fabric of connection thins under the weight of light time. They show you, step by step, how quickly real-time control fades as you walk up the ladder from light seconds to light minutes to light hours. Beyond Saturn, the ladder continues, but even here, within the familiar orbit of our own star, the pattern is already complete. Your species can reach, can observe, can send machines and someday people to other worlds. What it cannot do is bring them fully inside the same moment. The speed of light will not allow it. Understanding that is not an act of surrender. It is an act of clarity. It lets you see that the universe is not a single, tight web of instant feedback, but a scattered set of islands linked by signals that are always late. Mars and Saturn are two of the nearest of those islands. Already, they are far enough to end real-time control and to begin, in its place, a different way of existing together, one built on trust, planning, and the acceptance that sometimes, by the time your voice arrives, the world you are speaking to has already taken another step. By the time your voice takes minutes or hours to reach what you are talking to, it already feels less like a dialogue. By the time it takes almost a day, the connection turns into something else entirely. Voyager 1 lives in that something else. Mysterious. On paper, it is simple. Voyager 1 is a space probe launched by NASA in early September of 1977 from a launch pad in Florida, riding a Titan rocket into the sky. Its original task was modest by cosmic standards: fly past Jupiter, then Saturn, take pictures, measure fields and particles, and send back what it found. A planetary mission, a few years long, another chapter in the unfolding story of the space age. The misunderstanding starts when we call it the farthest we have ever gone, and imagine that phrase means we are now somewhere far in the direction of the stars. As of the middle of the decade we are in, Voyager 1 is a little over 24 billion kilometers from Earth, roughly in the range of 25 billion kilometers, depending on the day you check. That is beyond the orbit of Pluto, beyond the region where the solar wind dominates, in what we now call interstellar space. It is also, quietly, still very close to home on the scale of the galaxy. The more important number is not the distance in kilometers. It is the time light takes to cross that distance. Signals from Earth now need close to a full day to complete a round trip, many hours to go out, many hours to come back. Recent estimates put the one-way light travel time at a little under one full day, in the ballpark of 23.5 hours, and climbing steadily. Within the next year or two, Voyager 1 will reach a symbolic milestone, exactly one light day from Earth, a place where even a perfect, noiseless beam of radio waves needs one entire Earth day just to say hello. As reprises, it is tempting to turn that into a victory banner. One light day, the phrase sounds huge, triumphant, like a prelude to light years. You can almost feel the headline: humanity has pushed a machine an entire light day into the dark. But pause for a moment and look at what that really means. One light day is the distance light travels in one Earth day. There are about 365.25 days in a year. That means one light day is roughly 1/365th of a light year. If Voyager 1 is about to reach one light day from us, it has crossed only a tiny fraction of the distance that light covers in a year. Put differently, if you drew a line from Earth to the nearest star beyond the Sun, Proxima Centauri, which sits more than 4 light years away, Voyager has so far taken us about one day along a journey of over 1,400 days of light travel. Our farthest machine has barely stepped off the doormat of our stellar neighborhood. This is not a criticism of the mission. Voyager 1 is astonishing. It has been flying for nearly half a century. It has survived radiation belts, planetary flybys, the dwindling of its own power source. It has crossed the heliopause, the boundary where the solar wind gives way to the interstellar medium, something no other human-made object had done before. Its radioisotope power generators still keep a few instruments alive, and engineers continue to coax new life out of old hardware, even restarting long idle thrusters to keep the antenna pointed home. The misunderstanding lies in what we let that word farthest do to our sense of scale. When you hear that Voyager 1 is more than 24 billion kilometers away, that it is in interstellar space, that it is one light day from Earth, it is natural to imagine that we have, in some way, begun to occupy the space between the stars. The mind quietly translates farthest into "we are getting there." It imagines a slow but steady progress outward. As if distance were a ladder, we are climbing one rung at a time. But Voyager is not a step on a ladder that leads smoothly to other suns. It is more like a thrown stone that will never reach anything in particular. Its velocity relative to the Sun is around 17 kilometers per second, which is extraordinarily fast by spacecraft standards. About 3.5 astronomical units per year. Even so, at that speed it would need on the order of tens of thousands of years, roughly between 17,000 and 18,000 years to travel a single light year. That is the scale mismatch hidden inside the Pride. We have built a machine that has outrun every other machine we have ever made. And yet, in terms of light years, it has barely begun to move. By the time Voyager 1 has drifted 1 light year from the Sun, every person alive today will have been gone for a very long time. The cultures, languages, and maps of that distant future will almost certainly be unrecognizable. Our farthest is an infant step in a story that does not belong to us. There is another misunderstanding around Voyager, one that has less to do with numbers and more to do with presence. We often talk about it as if it were an extension of ourselves, a tiny ambassador of Earth carrying a golden record with sounds and images of our planet. That record is real, etched with music, greetings, and diagrams. It is a message in a bottle launched into a sea so vast that the bottle is almost guaranteed never to be found. Yet the way we frame it, "we have sent our message to the stars," can quietly distort what has actually happened. Voyager 1 is not in conversation with the galaxy. It is not on course to rendezvous with any particular world. According to trajectory studies, in about 40,000 years, it will pass within roughly 1.5 light years of a dim star in the constellation of the Giraffe, and hundreds of thousands of years later, it will brush past another star at a similar distance. In astronomical terms, these are near misses. In human terms, they are untouched. So what is Voyager really doing? It is showing us, in the clearest possible way, what it means for distance and delay to be intertwined. Every bit of data it sends about magnetic fields, charged particles. The density of the plasma around it takes nearly a full day to arrive. By the time engineers on Earth see a number on a screen, that number describes a state that Voyager has already left behind. Commands sent back to adjust instruments, to change modes, to stretch a little more life from the system, take another long stretch of hours to arrive. Every exchange is a 2-day conversation between a planet and a machine, with silence in between. This is not an accident of limited technology. Even if Voyager's transmitter were 1,000 times stronger, even if our antennas were 1,000 times more sensitive, the signals would still need the same time to move. The limit is not in the hardware, it is in the structure of space-time. Voyager lives beyond the point where real-time control is possible. It has become, by necessity, something closer to a semi-independent observer, following a path and running a program that cannot be rewritten moment by moment. In that sense, the probe situation mirrors a softer truth about ourselves. As you move through life, the influence you have on distant events always arrives late. Decisions made elsewhere reach you as news, long after they have been taken. Your own choices ripple outward as consequences that you may never see. You can plan. You can send your voice out in the form of actions, creations, children, stories, but you do not control what they become far away from you in time or space. Voyager is that idea, made literal and precise. It is a piece of human intention, traveling beyond any hope of direct guidance, carrying our designs and our message into regions where no one is watching in real time. One day, not very far from now, on the mission's own scale, its power will drop below the threshold needed to run instruments. Later, it will drop below what is needed to send a coherent signal at all. NASA expects science data to cease sometime in the coming decade, with engineering data fading after that. When the last transmission arrives, a day after it was sent, Voyager will not notice the difference. It will simply continue on its path, a silent object coasting through the dark, still carrying its golden record, still separating itself from everything we know at roughly the same steady speed. From our side, that final fade is often described as an ending, a mission complete, a chapter closed. But the trajectory does not end. It continues for hundreds of years toward the distant shell of icy bodies we call the Oort cloud. Then for tens of thousands of years more into the general flow of stars, Voyager will outlive our institutions, our languages, and very likely our species. It will be, for a while, one of the few traces of humanity moving freely between stars. And yet, even dressed in that kind of poetry, the hard fact remains, at one light day, we have barely moved a measurable distance compared to the size of the galaxy. Voyager's journey is an act of humility, disguised as an act of reach. It shows us, with every additional hour of signal delay, just how quickly our sense of closeness evaporates once light travel time stops being negligible. So when you hear Voyager 1 is the farthest human-made object from Earth, you can let the pride be there. It is earned. But you can also let another feeling sit beside it, the awareness that even our farthest has only begun to trace the first tiny arc of what distance really means. The probe is not proof that the universe is within our grasp. It is a marker, placed one light day away, reminding us how much of the universe will always remain on the far side of delay. It turns out that a single light day is already beyond our grasp. And yet, in the language the universe prefers, that is still just a fragment, the first distance that really belongs to the cosmos, rather than to us, is 1 light year. A light year sounds like time because your life is measured in years. A year is birthdays, school calendars, tax seasons, the slow aging of faces, you know. It is the way you count your own existence. But in astronomy, a light year is not a span you live through. It is a span you cannot cross. By definition, 1 light year is the distance that light travels in the vacuum of space in 1 Earth year. To get there, you multiply the speed of light about 299,792 kilometers per second by the number of seconds in a year, a little more than 365 1/4 days. Each day, 24 hours. Each hour, 3,600 seconds. The result is a distance of roughly 9,460,000,000,000 kilometers. You can carry that figure in your head. You can repeat it. You can write it down and test students on it. But your legs will never feel it. Your lungs will never move across it. It does not enter your body the way a walk around a city does. It lives entirely in the realm of thought and symbol. And yet, compared to the distances between stars and galaxies, 1 light year is small. That is the first strange thing about it. On human scales, it is unthinkably huge. On cosmic scales, it is a minimum meaningful increment, the smallest ruler that does not immediately fill up with zeros. Think of how clumsy the kilometer became once we left the solar system. To describe the gap between the Sun and the nearest star beyond it, Proxima Centauri, you can say more than 4 light years, or you can say about 40 trillion kilometers. Both are mathematically legitimate. Only one of them tells you something your mind can actually work with. 40 trillion kilometers is a wall of syllables. It does not tell you how the universe behaves across that gulf. More than 4 light years does. It tells you that any message exchanged between here and that star must take more than 4 years one way. It tells you that the newest possible information you can ever receive from there is already 4 years old. It ties distance directly to delay. In that sense, 1 light year is the smallest distance that finally makes a new kind of sense. It does not make sense as something you could traverse. It makes sense as a measure of how badly separated two regions of space are forced to be. With light seconds and light minutes, you can still imagine conversation. A 1-second delay is awkward but tolerable. A 10-minute delay is frustrating but manageable if you accept that you are really writing letters, not chatting. By the time you reach a 1-year delay, whatever you are doing is no longer conversation in any familiar sense. You are exchanging pieces of history. 1 light year is where this change becomes unavoidable. Imagine, for a moment, that there is a planet exactly 1 light year away, inhabited by something capable of building radios. If they send you a simple message, just "hello," you will not receive that greeting until 1 full year after they decided to send it. If you immediately reply, your answer will not arrive for another year. 2 short words, 2 years of silence in between. If either side wants to ask a question whose answer matters to their own present, should we help? Are you still there? What just happened? They will always be too late. By the time any information crosses the gap, the events that prompted the question will have already settled into the past. 1 light year makes that time structure explicit. It is the radius within which meaning can just barely pretend to keep up, and beyond which it never will. There is a quiet existential edge to this. Your own life might span something like 70 or 80 Earth years if you are lucky. That is 70 or 80 swings of your planet around the sun. 70 or 80 passes of the stars across your night sky as the seasons repeat. In terms of light travel, your entire lifetime is less than 100 light years of distance. If you could somehow ride on the front of a light wave the whole time, but you cannot. Your body moves at speeds that make even a fraction of a light year absurd. The fastest spacecraft humanity has ever launched, moving at tens of kilometers per second, would need tens of thousands of years to cross a single light year. That means that, in practice, 1 light year is not just the distance light travels in a year. It is also a way of saying forever, as far as you are concerned. Minus to grow, and 5 low. At the same time, the unit has a strange gentleness. It is not bombastic. It does not shout with a forest of zeros the way trillions of kilometers do. It simply states, if you move at the fastest allowed speed, this is how long it takes. 1 year of travel per light year of distance. 2 years there and back if nothing moves in the meantime. A simple linear rule imposed on a universe that is anything but simple. Astronomers lean on this unit because it keeps their sentences honest. When they tell you that a certain star is 10 light years away, they are telling you that you see it as it was 10 years ago. When they say a galaxy is tens of millions of light years distant, they mean you are looking tens of millions of years into its past. It is not just that the object is far, it is that the object you think you are looking at no longer exists in that state. And the light year counts precisely how out of date your view must be. For everyday life, that sounds irrelevant. Who cares if you see a galaxy as it was millions of years ago, when your own life is measured in decades? But this is exactly where the light year begins to reshape how you think about reality. You are used to assuming that what you see is what is there. Now, the light year quietly denies that. At least beyond a local bubble, it says, what you see is always a version of elsewhere, lagging behind its own present. And the amount of lag is written directly into the distance. Consider again Voyager 1, approaching the mark of 1 light day. If we could somehow push a probe to 1 light year, the delay would not simply be a little longer, it would change the nature of the relationship. A mission team on Earth could not reasonably think in terms of adjusting plans in response to current conditions. By the time any status report arrived, the probe would be a year older. By the time any corrective command reached it, it would be older still. A 1 light year mission is not an expedition in the way you usually picture. It is a message in one direction. with the possibility of a reply that belongs to a later generation. By choosing to use light years, you admit that, up front. This is why. Paradoxically, 1 light year is the smallest distance that really fits the universe. It forces you to think the way the universe actually works. Seconds and minutes and kilometers belong to the human scale, where immediacy still feels possible. Light years belong to a reality in which immediacy is local, and everything else is delayed beyond any individual's reach. It is also why the popular misunderstanding of the light year as if it were just a gigantic, dramatic measure of how far, in a vague sense, misses the point. The usefulness of the unit is not in its grandeur. It is in its precision. 1 light year tells you exactly how disconnected 2 places must be, how much of each other's history they are forced to miss. From that perspective, the universe starts to look less like a grand arena filled with participants watching each other in real time, and more like a vast collection of small, bright pockets of now, each separated from the others by light years of unavoidable delay. Within each pocket, meaning arises in the same way it does in your own life, through fast feedback, shared events, mutual change. Between pockets, there are only signals in flight, carrying news that will never quite be current when it arrives. 1 light year is the smallest unit that captures this structure honestly. Anything less allows you to pretend that synchronicity might still stretch a little farther. Anything more becomes so large that the numbers start to lose their connection to lived experience again. At 1 light year, the mask slips just enough. You can still hold the number in your mind, but it is clear that you cannot hold the distance in your life. Standing under the sky, you will never feel a light year in your muscles or your breath, but you can feel what it does. It folds distance and time into a single statement about separation. It tells you, gently and without drama, that the universe is not merely large, it is late. And that lateness is not an accident to be fixed, but the way reality is stitched together, 1 light year at a time. The moment you accept that 1 light year is already beyond any life you will ever live, the phrase nearest star begins to sound less like comfort and more like a question. Proxima Centauri is the answer to that question, at least in a technical sense. It is the closest star to the Sun, a dim red dwarf tucked into the same gravitational family as the brighter Alpha Centauri pair. From Earth, it hides in the southern sky, invisible to most of the northern hemisphere. A modest point of light that does not look like the frontier of anything. Science tells us it sits at a distance of a little more than 4 1/4 light years from the Sun. That is the headline number, 4 and a bit light years. Short enough to sound almost friendly. In a world where you might hear about billions of light years to distant galaxies, 4 sounds practically next door. The misunderstanding begins right there, in the way that word nearest reshapes the scale in your head. If you insist on kilometers, the distance is around 40 trillion kilometers. You can say that out loud, but you cannot see it. 40 trillion is already past the point where numbers behave like measures. It is a label that simply means farther than you were ever meant to walk, drive, or fly. If you want to change us in the stames, the light year cuts through that abstraction in a different way. To say Proxima Centauri is a little more than 4 light years away is to say that light itself needs a little more than 4 years to get there from here. 1 photon leaving the Sun today, headed in exactly the right direction, will not pass that star until several Earth calendars have been taken down and replaced. If you send a radio message, it will take the same time. If, in some distant future, you send a ship that could somehow ride the speed of light, its journey would be measured in years, not months. Now, fold in something more human. The fastest spacecraft we have ever launched, Voyager 1, moves away from the Sun at a speed of around 17 kilometers per second. At that pace, It would take on the order of tens of thousands of years to cross a single light year, and well over 70,000 years to reach the current position of Proxima Centauri, if it were even heading in that direction. 70,000 years is longer than recorded human history. It reaches back before agriculture, before cities, before writing, into a time when our ancestors were simply trying to survive and the constellations had no names. So when you ask, how long would it take us to get to Proxima Centauri now? The honest answer is, longer than your species has yet managed to remember its own past. This is what nearest means in a universe that measures distance with light. It is natural to resist that. When you see illustrations of Proxima Centauri and its planets, you might feel a faint tug of belonging. There is at least one rocky world there, Proxima Centauri b, roughly similar in mass to Earth, orbiting close to its dim star. You may have read that it lies in the so-called habitable zone, where starlight is. In principle, gentle enough for liquid water to exist on a surface. The imagination does the rest, oceans under a red sun, alien skies. Another place where life could cling and think and look back. The misunderstanding is not in hoping such worlds exist, but in quietly treating 4 light years as if it were a gap you might someday cross in person. Given enough courage and technology, it feels as though the only obstacles are engineering and patience. But 4 light years is not a hard project, it is a hard limit. At least for beings whose bodies have lifetimes measured in decades and whose machines decay over centuries. You can calculate the energy needed to push a substantial ship to a significant fraction of light speed. You can draw up blueprints for generational vessels, hollowed asteroids, laser sails, fusion drives. People have done all of that. The physics does not forbid motion. It forbids simultaneity, even if you reached some ambitious fraction of light speed, say a fifth. The kind of number occasionally proposed in far future studies for laser-pushed sails, a one-way trip to Proxima Centauri would still take more than 20 years as measured from Earth. For the people on board, relativistic effects would trim that time slightly, but not enough to turn it into a casual voyage. And that assumes technologies far beyond anything we have actually built, operating flawlessly over decades in deep space. It assumes a level of collective will and stability that human societies do not often manage, even within their own borders. So, the phrase, "still unreachable," is not pessimism. It is a description of how thin the bridge can realistically be. Proxima Centauri is not a weekend trip. It is a multi-decade commitment, even in optimistic scenarios, and a multi-millennial drift at the speeds we can achieve today. For any individual, it is out of reach. For any single culture, it stretches beyond planning horizons. The star is close in the language of astronomy and effectively infinite in the language of human experience. There is another layer to this, quieter but just as important. Even if no ship ever goes, light already travels between us and Proxima. That traffic is constant. Photons from the sun are sweeping past that star. Photons from Proxima are arriving here, spiking and fading as its flares erupt. If there is a listener there with instruments like ours, they could, in principle, detect Earth as a pale point, track our orbit, read the spectrum of our air. But whatever they see is old. Right now, if someone on a planet around Proxima pointed a telescope toward the sun, the Earth they would detect would be the Earth of more than 4 years ago. If they were watching in the late 1970s, they might be just now seeing the faint signatures of our early digital age. If they watch for centuries, they could build a delayed history of our climate, our industrialization, our shifting atmosphere. We, in turn, would see them as they were, not as they are. This is the deeper meaning of nearest. The closest strangers we could possibly have in the galaxy would still know us only as a sequence of past versions, and we would know them the same way. Any exchange would be an exchange between ghosts of each other's earlier states. Suppose, for a moment, that there is intelligent life on Proxima Centauri b, and that they decide to send a deliberate signal. They beam a narrow stream of radio waves toward our sun, encoded with whatever they think represents themselves a pattern. A prime number series, a burst of music in some unfamiliar scale. That signal leaves their world and begins its 4-year journey across the dark. By the time we detect it, 4 years have passed here. Whatever prompted their transmission, their political climate, their discoveries, their fears has moved on. Perhaps it has strengthened. Perhaps it has collapsed. We do not know. We try to respond. Our answer begins its own 4-year journey back. 8 years after their original decision, a reply washes over their star into whatever detectors they have. If any, already, the world on each end is out of sync with the one on the other. Maybe the original scientists there have aged out of their roles. Maybe a catastrophe has interrupted their listening. Maybe nothing significant has changed. There is no way for us to coordinate that. Multiply this across decades, and any conversation becomes a chain of messages that belong to different eras. Children answer questions asked before they were born. Signals arrive for cultures that no longer exist. Silence can mean many things. You cannot tell whether a quiet channel is a choice, an accident, or simply the result of being outlived. So, Proxima Centauri is nearest in a way that matters to light and numbers, but not in a way that rescues you from isolation. The limit is not just your engines. It is the fact that time and distance are tied together so tightly that even your closest stellar neighbor lives in a slightly different timeline. There is a temptation, in the face of this, to imagine that someday we will simply sidestep the problem. Discover some faster-than-light trick, a shortcut through space, a wormhole. These ideas appear often in stories, and they make for good stories because they treat the speed of light as a technical nuisance to be engineered away. But current physics does not offer such exits. The structure we see is one in which light sets the maximum speed for influence, and Proxima Centauri sits safely on the far side of that rule. What does that leave you with? Not despair, though it might flirt with it. What it leaves is a clearer sense of the size of your local sphere. Within a few light seconds, you can move and speak and be answered as if you share one present. Within a few light minutes or hours, you can coordinate imperfectly, trusting that the world will not change too much between question and response. Beyond that, at the scale of light years, even the nearest star becomes a place you can only ever know through delayed light and possibly delayed words. Meaning, then, is forced to arise in smaller spaces. In the room where your voice is heard without perceptible lag. In the orbit of your planet, 8 light minutes from its star. In the thin shell of space where real-time control still makes sense. Proxima Centauri is close enough to see clearly and far enough that your lives will never touch it in person. Standing under the night sky, you might feel a strange mix of comfort and distance in that fact. On the one hand, you are not hemmed in by walls. The universe stretches out, and the nearest star really is only a few light years away. On the other hand, those few light years are enough to ensure that, for all practical purposes, you and that star will always be strangers exchanging old news. Nearest does not save you from that. It only gives you a precise name for the first point in the cosmos where the limits you live under become undeniable. The word nearest leaves a bruise. And the mind does what it always does with bruises. It dreams of getting stronger. If 4 light years is too far, it whispers, then move faster. The idea of near light speed feels, at first, like a reply to the universe's indifference. If light is the fastest messenger allowed, then getting close to that speed sounds like a kind of rebellion. We cannot cheat the limit, but we can at least chase it, not crawl toward the stars, but streak. Unlike the fantasy of instant travel, this dream has teeth because it does not ask physics to change. It accepts that nothing outruns light and instead asks a different question. How close can we get? One serious answer has a name. Concepts like breakthrough starshot. Imagine sending tiny probes, no heavier than a paperclip, pushed by enormous ground-based lasers until they reach perhaps 15 to 20% of the speed of light. At that pace, a journey to the Alpha Centauri system, including Proxima Centauri, might take on the order of 2 or 3 decades, with another 4 years for the data to come back on a beam of light. The numbers are still brutal, but they are different. 20 or 30 years is long, yet it fits inside a human lifetime. A child could see such a mission launched and grow old alongside its flight, perhaps living just long enough to witness the first fuzzy images from another star. For the first time, the gap to a nearby system shrinks from mythic timescales. Tens of thousands of years at Voyager speeds to something measured in decades. That is the first layer of hope. The second layer is more technical. The starshot vision does not lean on unknown physics. It uses ordinary photons, fired from an immense phased array of lasers on or near Earth, to push a reflective sail. The sail itself is imagined as an ultra-thin, meter-scale sheet, perhaps only hundreds of nanometers thick, made from carefully engineered materials that can survive both the heat of the accelerating beam and the cold of interstellar space. In that story, the probe is tiny mass on the order of grams. The power system, cameras, communication laser, and navigation all have to fit onto something closer to the size of a coin than the size of a car. The pushing beam, by contrast, is huge. Concepts talk about laser arrays with total power on the order of 100 gigawatts or more, spread over many individual emitters and focused through kilometer-scale optics onto the receding sail. It is ambitious, but it is not magic. Every piece looks, at least in outline, like an extrapolation of technologies that already exist in smaller, weaker, less polished forms. This is where the misunderstanding creeps in. When people hear a fifth of the speed of light, or a journey of only 20 years to Proxima Centauri, it is easy to slide from, in principle, a gram-scale probe to, in principle, us. The mind rushes ahead to crude starships, vast habitats, entire communities coasting between suns at relativistic speeds, sending messages home as they go. It feels, for a heartbeat, as if division by light years is almost over, as if near light speed were a bridge rather than merely a narrower gap. In reality, the teeth of this hope bite both ways. Start with the engineering bite. To reach near light speed, the sail must survive accelerations thousands of times stronger than the gravity you feel on Earth's surface. The material cannot melt under the focused laser, cannot tear under its own tension, cannot warp in ways that throw it out of the beam. The guidance system has to keep the sail aligned despite tiny imperfections that, at such accelerations, behave like hammer blows. Then there is the medium between stars. Interstellar space is thin, but not empty. Dust, grains, and stray atoms drift there, moving slowly compared to light, but terrifyingly quickly compared to a fragile probe. At 20% of light speed, even a speck of dust smaller than a grain of sand carries enough kinetic energy, relative to the spacecraft, to hit like a bullet. Studies for starshot estimate that each square centimeter of frontal area might collide. Over the course of such a journey, with on the order of thousands of tiny particles, protecting against that without increasing mass, so much that acceleration becomes impossible, is not a side note. It is one of the central problems. Push too hard on armor, and you lose the very thing that made near-light speed attractive, a probe so small and light that an absurdly powerful laser can fling it outward in minutes. These are technical teeth, and given enough time and effort, some of them might be filed down. Materials improve. Nanofabrication advances. Our ability to coordinate vast energy systems and control coherent beams over enormous distances may grow. The research already happening on ultra-thin, nanostructured sails is evidence of that slow grind forward. But there is another bite that does not dull with progress, even at near light speed. The universe stays out of sync. Imagine, for a moment, that Starshot or a successor actually flies. A suite of gram-scale probes, each with a shimmering sail, is released into high orbit. A pulse of laser light drives each one to a significant fraction of light speed in a few minutes. Then they coast, tiny and fast, into the dark. 20 years later, the first arrives in the Proxima system and begins to shoot back images, spectra, compressed data through a pencil-thin communication beam. By the time those first bits of information wash over Earth, 4 more years have passed. The team that launched the mission has aged a quarter century. Some of them are gone. The world that decided to spend its money and attention on such a project is not the world that receives the results. Children who were not yet born at launch might be the ones to analyze the data. Political systems might have shifted. Crises will have come and gone. Near light speed does not restore conversation. It shortens the delay to a scale that fits inside history, but not inside a single life without stretching it. The people who send the message are rarely the ones who will live with the full consequences of the reply. If you take that seriously, the dream becomes something different from the way it is often advertised. It is not about humans voyaging to other suns in person, at least not in the forms we currently understand. It is about building instruments that can leave us behind, physically and temporally, and trusting that the civilization that greets their findings decades later will be able to understand them, ethically and technically. There is a quieter, more personal reflection hiding in this. Every long project in human life already shares this shape in miniature. You start something, a relationship, a piece of art, a movement. A child knowing that the full meaning of what you begin will unfold in a time you cannot fully occupy. You see some results, early ripples. The farther ones are left to others. Near light speed missions simply stretch this pattern across light years, making it too obvious to ignore. And then there is relativity's own twist. As an object approaches the speed of light, time for that object, as measured by an outside observer, slows down. If you could somehow ride inside one of those near light speed probes with enough room to live, your own clock would tick more slowly than the clocks on Earth. You might experience the trip to Proxima as somewhat shorter than 20 years. From your point of view, the journey could compress into a span that feels survivable. Even if, back home, more time passes, stories often cling to that idea as a loophole, as if time dilation were a gift granted to travelers to ease the pain of separation. But relativity is impartial. While your time slows relative to the outside keeps going. When you arrive, the Earth that launched you will be older than you expect. People you knew will have lived through years you skipped. They will have memories of events that, for you, never existed. If you come back, you will be the one arriving like a message from the past. Near light speed, then, does not defeat the structure of delay. It merely redistributes it. Some of the waiting moves into the frame of the traveler, some into the frame of those who stay. But the difference between here and there, now and then, remains fixed by light itself. None of this makes the dream useless. In fact, it is what gives it real weight. A hope with teeth is one that survives contact with limits. If we ever do send near light speed probes to Proxima Centauri or beyond, they will be built in full awareness that they are not chariots carrying us to a shared cosmic present. They are couriers of information, launched once, largely unsteerable, bearing whatever fragment of our curiosity we can fit into grams of matter. When we receive their returns, if we do, We will not be meeting neighbors. We will be opening envelopes that contain a frozen, delayed glimpse of some place that will already have changed again. The gap will be years instead of millennia, which is astonishing. It will still be a gap. In that sense, the dream of near light speed is not a way out of loneliness. It is a way of approaching it honestly. It asks, knowing that separation and delay are built into the universe, how far are we willing to go to send a small piece of ourselves across that distance anyway? Without guarantee, without control, without being there when it arrives? Hope can cross a light year, but replies cannot hurry. Once you really feel that, the idea of talking across the stars starts to change shape. Most of the time, when people imagine communication with another world, they picture a scene that looks suspiciously like a phone call. A clear message goes out, some suspense, and then an answer returns while the original senders are still in the room, still watching the same screen, still alive to feel the moment. It is the emotional template of a conversation, call and response within a shared present. Light years do not permit that kind of present. Take a simple thought experiment. Imagine there is a civilization on a planet exactly 10 light years away. Not tens of thousands. Not on the far side of the galaxy. Just 10. Close. By cosmic standards, our telescopes notice odd patterns in their radio emissions. We decide, carefully, to send a deliberate message. We build an enormous transmitter, point it at their star, and beam out a tightly focused stream of radio waves filled with whatever we think represents us. Mathematics, diagrams, maybe music, maybe a picture of our DNA, maybe something simpler and more honest, like a repeated pattern that just says, "We know you are there." That message takes 10 years to arrive. In those 10 years, governments change, children are born, people grow old, fashions evaporate, crises flare and fade. By the time the signal washes across their world, everyone who participated in the first debates about whether to send it is 10 years older. Some of them are no longer here. For the hypothetical beings on the other side, our message is already a historical document. It carries the imprint of what we were a decade ago. Suppose they hear it. Suppose they understand that it is artificial, and not just some peculiar pulsar or planetary static. Suppose they decide to answer. They beam back whatever counts as a greeting for them. Their reply begins its own 10-year journey. When their answer finally appears as a faint, structured whisper in our detectors. 20 years have passed since our original decision to speak. The room where the first signal was sent may no longer exist. The people who argued about the wording might have retired, or died, or become footnotes in documentaries. The reply falls, instead, into the hands of a different group, younger scientists, younger politicians, younger children watching the news, living in a world already shaped in small ways by that earlier act of reaching out. Call and response have become generational. That is for 10 light years. At 20 light years, a single exchange takes 40 years. At 50, it is the span between a teenager and someone at the end of their life. At 100, almost any human handshake across the gap is gone. You can keep extending the number, but the pattern is the same. As distance grows, the round-trip time for even the shortest back and forth stretches past the length of a life. The misunderstanding here is subtle. It is not that we cannot send and receive signals across light years. Physics allows that easily. It is that we keep imagining those signals as part of conversations in the ordinary sense, when really they are more like letters placed in a relay that spans generations. We already have a small taste of this on Earth. Before light years ever enter the story, a letter carried by ship can take months to cross an ocean. A response takes months to return. Someone who went to war in one century might receive news of a child's birth long after the child has learned to walk. Even in the age of instant messaging, You can still open a book written centuries ago and feel, for a moment, as if the author is speaking directly to you, when in fact you are only reading the preserved pattern of thoughts from a person whose body dissolved long before you arrived. Interstellar communication is this, stretched until the delay is no longer accidental or optional, but structural. Consider the messages we have already sent. In the mid-1970s, a focused radio signal was beamed from a large telescope toward a globular cluster of stars thousands of light-years away. It was a symbolic act, a carefully crafted message including simple images and numbers. We know, with clean, unforgiving certainty, that no one alive at the time of that transmission will be alive when those waves reach their target. Or if any answer ever returns, that does not make the act meaningless. It simply means that its meaning, if it ever crystallizes, will belong to people who never shared the original hope firsthand. You can see this pattern emerging in more grounded proposals too. If we one day establish a small, fragile settlement around another star, 4 or 10 or 20 light-years away, there will almost certainly be a communications link. Narrow beams of data will pass between their world and ours. News, images, technical updates, personal letters will flow back and forth, but the rhythm of those exchanges will not resemble any communication pattern we know now. A message from a parent on Earth to a child born on that distant world might take a decade to arrive. A reply from that child, if they choose to send one, will take another decade. For the two individuals involved, the contact may consist of only a handful of messages across an entire lifetime, each one responding not to who the other person is now, but to who they used to be. At the level of politics and culture, the effect is even more pronounced. A policy change on Earth intended to help or control an off-world colony would arrive years after it was written, trying to govern conditions that might have already shifted. Any protest or plea from the colony would arrive back on Earth years after the triggering events. By the time debates concluded and new decisions were made, the situation that sparked them would have turned into history on the other end. In this setting, conversation becomes something closer to tradition. Each generation inherits not only technology and stories, but also a backlog of messages written by people who are no longer around. They are asked to answer questions they did not hear when they were asked. They must interpret intentions across gaps, not just of distance, but of time and experience. The existential texture of this is difficult to ignore. On some level, it is already your situation. You are shaped by decisions made before you were born. You carry ideas, languages, habits that arrived as messages from the past, encoded in institutions, books, customs. When you act, you send your own signals outward into the minds of others now, into the future that will remember or forget you. Communication across light years does not invent this structure. It exposes it, stripped of the illusion that everyone involved could, in theory, get into the same room and argue it out. There is another misunderstanding wrapped up in the way we talk about first contact. We often imagine it as a singular event, a moment when a clear signal is received, decoded, and answered, and the universe goes from silent to speaking in an instant. Lights flash. Headlines appear. Everything changes. In a universe ruled by light years, any real contact would be more like the slow unfolding of a correspondence with someone whose letters arrived decades apart. The first message would almost certainly be ambiguous. It might be a repeated pattern, a narrowband signal, a burst that stands out statistically against the background noise. It might take years of re-observation and analysis before we even agree that it is not a natural phenomenon. If we chose to respond, our answer would be built not just by scientists, but by committees, governments, artists, people arguing about what it means to speak for an entire planet. That process alone could take years. The reply would then travel for years. At every stage, The people involved would be changing. Some would leave the conversation. Others would join, having never known a world in which the signal did not exist. By the time a second message arrived, it would be answering a version of us that no longer exists. This does not make the whole idea futile. It simply relocates the center of the story. Interstellar communication, if it ever happens, will not be about quick exchanges of information. It will be about how societies choose to behave in the face of replies they will never personally hear. Whether you send a message at all becomes less a question of personal curiosity and more a statement about what you think future generations should inherit. Do you launch a beacon into the dark, knowing that it may attract attention from something you cannot control? Perhaps centuries from now? Do you answer if someone else does the same? Do you, as a culture, accept the responsibility of beginning conversations that will outlive you, knowing you cannot stage manage their end? The speed of light turns these into practical, not philosophical, questions. It guarantees that whatever you send across light years will belong, in its reception, to strangers. You can try to predict their needs and fears. You cannot ensure they will share yours. There is a gentler side to this. 2. The same delay that keeps us from synchronizing with hypothetical others also softens the fear of them. If a civilization 10 light years away decided, unambiguously, to harm us, the light-year gap would still apply. Any physical attempt to cross that distance would operate on timescales that give plenty of room for adaptation or irrelevance. Any signal intended to mislead or frighten would unfold slowly, leaving room for reflection. The universe is not an arena for fast reactions between distant players. It is more like a slowly evolving archive of signals, many of which never meet, most of which arrive after their senders have become part of the background. Seen this way, communication across light years is less about shrinking the universe and more about acknowledging its size. It asks you to accept that meaning can be transmitted without control, that questions can be asked without guaranteed answers, that replies can arrive for people who did not know they were part of the conversation. You already practice this, in quieter ways. When you speak honestly to someone, you cannot predict how your words will land inside them over years. When you create anything that lasts, writing, music, structures, you are sending out a kind of signal to readers and listeners you will never meet. The delay is less cleanly measurable than a light year, but the structure is the same. The cosmos simply stretches that structure until the illusion of instant feedback breaks completely. Across light years, every conversation is a sequence of messages that outlive their senders. Stitched together by light, moving at the only speed it can, what remains is not the fantasy of a single shared moment, but the quieter, a stranger possibility that understanding can still emerge between beings who never once occupy the same now. It was note when to. There is a kind of patience in the way light moves across space. Then, at a certain scale, patience is no longer enough. Beyond that, even waiting forever will not help. From where we sit, the universe looks like a sphere, not because it really ends in every direction, but because light has only had a limited amount of time to reach us. The age of the universe is currently estimated at about 13.8 billion years. If you imagine that span as a simple distance, you might expect the farthest things we can see to be about 13 or 14 billion light-years away. They are not, because space has been expanding while light travels. The most distant galaxies, whose light is now reaching us, are calculated to be more than 46 billion light-years away, in what is called co-moving distance. In other words, the universe has been stretching under the feet of the photons the entire way. The result is a kind of shell, a boundary between what has had time to send us light and what has not. This shell is sometimes called the observable universe. It is not a physical wall. It is a limit set by time and by the speed of light together. Anything whose light has not had enough time to get here since the beginning of cosmic expansion simply cannot be part of our sky. That is the first horizon. The misunderstanding usually appears right away. It is tempting to think of this horizon as temporary, as if given enough billions of years, more and more of the universe will come into view until, eventually, everything becomes observable. The image is comforting, a darkness that yields, slowly but steadily, to observation. But the cosmos has more than one horizon, the observable limit, which cosmologists sometimes call the particle horizon, tells you how far light has traveled to reach you by now. The cosmic event horizon tells you something harsher, how far away something can be today and still ever manage to send light that reaches you in the future. Beyond that second horizon, no matter how long you wait, signals emitted now will never arrive. Current estimates put the distance to this event horizon at around 16 billion light-years, with models suggesting it will grow slowly toward a maximum of roughly 18 billion light-years as the universe continues to expand under the influence of dark energy. Those numbers are rough, and the details depend on how exactly dark energy behaves. But the broad picture is stable. There is a finite radius around us, beyond which the present actions of galaxies are forever sealed off. This is a different kind of limit. The particle horizon says, there are parts of the universe you cannot see yet. The event horizon says, there are parts of the universe you will never see at all. 18 the third. The word never is not one we use lightly in physics. It is easy to confuse we do not know how yet with we can never. But here, never has a precise meaning. In the standard cosmological model, galaxies farther away than the event horizon are receding from us because of the expansion of space itself. So quickly that even light sent directly toward us now will be dragged outward by that expansion and will never cross the growing gap. Nothing is moving through space faster than light in the local sense. Rather, space between us and those galaxies is expanding. General relativity allows this. The end result, from our point of view, is the same as if they had slipped over a waterfall we can never swim back up. We have seen a version of this idea already in miniature. A black hole has an event horizon, a boundary inside which light cannot escape to the outside universe. The cosmic horizon is a similar concept, but turned inside out. Instead of a small region you cannot look out from, it is a vast external region we cannot ever fully look into. The existential texture of that is easy to feel. It means that most of the universe is not just currently unknown. It is permanently unshareable. No matter how long your civilization lasts, no matter how perfect your telescopes become, no matter how cleverly you encode your messages, anything that happens beyond that horizon will never show up in your sky. You live inside a finite bubble of potential contact, surrounded by an outside that is, in practice, final. It is tempting to respond to this with scale. The observable universe is already enormous. Its co-moving radius is on the order of 46 billion light-years, giving it a diameter of about 93 billion light-years. That is a volume so large that numbers describing how many galaxies and stars it contains are themselves measured in tens and hundreds of billions. The part cut off by the event horizon is, in a sense, extra. We might tell ourselves that we already have more cosmos than we could ever meaningfully use. But this, too, hides a misunderstanding. The horizon is not about greed, about wanting more territory. It is about the structure of causality. It tells you which parts of the universe are, even in principle, part of your story. Imagine, for a moment, that an unimaginably advanced civilization lives in a galaxy just inside our event horizon. If they decide, today, to shine a bright beam of light toward us, that signal will, given enough time, arrive. It might take billions of years, but the path exists. The light's journey would be stretched, its wavelength pulled toward the red by the expanding space through which it travels. but it would eventually cross the gap. Now shift their galaxy slightly outward, just beyond the event horizon. The difference in distance might be small compared to the overall scale of the universe, but the consequence is stark. Any light they emit now, no matter how focused, no matter how long they keep sending, will never reach us. The expansion between us is simply too strong. The curve of space-time itself carries their signals away. From our point of view, those galaxies do not just happen to be out of sight. They are outside our future. The same argument runs in reverse. There are regions of the universe from which we are already permanently hidden. Light leaving Earth today will never be seen by observers in those places, no matter how long they wait. For them, our entire existence will be confined to a smaller, earlier patch of space-time. We are, quite literally, someone else's unreachable past. This is what it means for distance to become final. It may sound abstract, like a problem for theorists. Yet, quietly, it reflects a structure you already live inside. Even at human scales, there are horizons you cannot cross. Your lifetime is finite. There are conversations you will never have, books you will never read, places whose light will never fall on your eyes. In principle, you could imagine a life long enough and mobile enough to shrink those personal horizons. In practice, the span of years you get is limited. Some distances are effectively final for you, whether or not they are for the species. The cosmic horizon is this pattern written in geometry rather than biology. It says, there are events that will never occupy your now, no matter how long now stretches. Another misunderstanding lurks in the way we talk about the universe, as if it were a single object we can eventually map in full. Our instruments grow more capable. Space telescopes like Planck, Euclid, and the new generation of observatories have given us high-resolution maps of the cosmic microwave background, detailed surveys of millions of galaxies, and evidence that the large-scale structure of the cosmos follows patterns described by the standard model of cosmology. It is easy, watching this progress, to imagine a future in which we have something like a complete atlas of everything that exists. The horizon tells us that this is not how completion works. No matter how good our data becomes, our picture will always be drawn from inside, a finite, expanding bubble. The rest is not a blank we can someday fill. It is a region that does not belong to our possible knowledge. Strangely, this realization carries a kind of relief. If there were no horizon, no built-in limit, the responsibility to understand everything might feel crushing. With a horizon, the universe offers a boundary condition. This much is available, the rest is, by design, someone else's problem, or no one's. At the same time, the horizon sharpens what local means. It is not just your planet, your star, or even your galaxy that forms your neighborhood. It is the entire region that can still, in principle, exchange light with you. Within that region, cause and effect can, however slowly, interweave. Beyond it, reality unfolds without any chance of interaction. From the standpoint of meaning, that is where the book ends. Stories require interaction. They require feedback, however delayed. For one thing to matter to another, the cosmic event horizon draws a circle around the set of things that can ever be part of your chain of influence. You might never meet the vast majority of the galaxies inside that circle in any practical way. Your species may never venture beyond a tiny cluster of stars, but the fact that light can, in principle, cross those distances matters. It means that, in the deep fabric of space-time, you and those distant systems share a possible history, even if it is one that never happened. Outside the horizon, there is not even that. So the final misunderstanding is this, that the universe is a single, connected arena, waiting patiently for us to grow into it. The horizon reveals a different picture, The cosmos is fragmented by distance and expansion into domains that can never fully see or affect one another. We live in one such domain. Our instruments can show us its shape with increasing clarity. They cannot change the fact that there is an outside we will never touch. Under a night sky, that thought can feel heavy. Yet, it also quietly explains why meaning feels so concentrated in the small. Relationships, choices, fragile moments of understanding. All of them happen inside a very limited region of space and time, where signals arrive quickly enough to matter. The rest of the universe is there, immense and unreachable, setting the background conditions and then withdrawing. Light years are the way we measure that withdrawal. The cosmic horizon is where the measurement stops being about large numbers and becomes, instead, a simple sentence. Past this line, nothing you do will ever arrive. If you stay with all of this long enough, the light seconds and light years, the event horizons and one-way messages, something quiet happens in the background. The universe stops feeling like a place you are failing to reach. It starts to feel like a place that was never built for anything to be in touch with anything else for very long. Light, which once felt like a promise of connection, reveals itself as a ceiling. It does its best. It runs as fast as reality allows, but between stars, between galaxies, even between different regions of the same universe, that speed is not enough to keep anything synchronized. Every glance is late. Every signal is a fragment of a world that has already moved on. The distance is not just far, it is late by design. Inside that structure, your life takes on a strange kind of clarity. Your entire sense of now exists inside a tiny pocket where light travel times are so small that your brain rounds them down to zero. The room you are in, the city around you, the 8 light minutes to the sun. Within that narrow zone, feedback is fast enough that touch, conversation, cause and effect feel immediate. This is where love, conflict, boredom, work, laughter, and regret actually happen. Beyond that, everything becomes archaeology. The stars are not your roof. They are a delayed report. Even if there is someone looking back, they see an old version of you, and you would see an old version of them. The universe is not a shared stage. It is a collection of separated scenes, stitched together only by light arriving late. There is a kind of loneliness in that, but it is not personal, it is structural. The cosmos is lonely with or without you, and that, strangely, is where the weight lifts a little. Because if separation is built into reality, then your job was never to make everything connect. You do not have to stretch your life across light years. You do not have to carry the whole sky. Meaning was always going to be local, in the handful of people whose voices actually reach you in time, in the few places your body can inhabit, in the short chain of moments where your actions and their consequences still overlap. You are a small, brief arrangement of matter inside a universe that mostly does not notice itself. But in this tiny zone where light is fast enough and distances are kind enough, awareness has looped back on itself and seen the scale of the room it's in. Nothing arrives on time out there. Here, for a little while. Some things do. That is not an answer. It is just the shape of the prison and the small, bright courtyard where you actually live.